Question 5.32 from the homework, combustion analysis of pentane in the bomb calorimeter leads to a temperature change from 23 to 29 degrees Celsius. What's the delta H of the reaction, given that the heat capacity of the bomb calorimeter is 5.23 kilojoules per degree Celsius? So from that, we should think, well, I need to find what's the energy, what's the heat, right? Q that the calorimeter absorbed. So Q, the calorimeter, equals the heat capacity, C, times the change in temperature. My heat capacity is 5.23 kilojoules per degree Celsius, and my delta T, 29.8 degrees minus 23.7 is 6.1 degrees Celsius. The calorimeter went up. So the heat for the calorimeter is 31.903 kilojoules. So that's how much energy the calorimeter absorbed. And remember, we are looking for the heat of the reaction, and the Q of the reaction is the opposite of the Q of the calorimeter. So because the calorimeter absorbed 31 kilojoules of energy, the reaction released 31 kilojoules of energy. So the reaction was exothermic. So that's step one. We found out how much energy the bomb calorimeter absorbed. Now we need to find out the delta H for this reaction in kilojoules per mole. So I need to find out, okay, how many moles of pentane did I have present? So I've got 0.1523 grams of pentane, and I know, go to the periodic table of the elements, look up the atomic weight of carbon and hydrogen, the molecular weight of pentane, 72 grams. So 0.1523 grams in the sample divided by 72. Grams cancel out, got approximately 0.002115 moles of pentane. So now I know this heat came from this many moles of pentane, and my last step, right, would just be, how do I make kilojoules per mole? Well, I have kilojoules, I have mole, so if I divide those two, negative 31.903 kilojoules were released when 0.00215 moles of pentane were put through this bomb calorimeter. So the delta H for this reaction should be something on the order of 1.51 e to the fourth kilojoules per mole. And I did three significant figures because temperature, right, 23.7, there's only three significant figures there. The heat capacity of the bomb calorimeter, I guess, is also measured, and there's three sig figs there. So I went with three significant figures for the answer, and it's a negative energy, right, because this combustion reaction is exothermic. So hopefully that helps with question 32 from the homework.